Okay, let's dive into this. Welcome back to today's Explainer, where we're going to explore one of the absolute most critical, high-stakes turning points in any offshore project. We are looking at that exact moment when a massive, static structure of steel and pipe actually begins its transformation into a living, breathing facility. It's a total game changer. It's a fundamental shift that completely changes how you schedule work, how you think about testing, and ultimately how you manage your budget. To really grasp this transformation, we have to look at a massive paradigm shift. You see, construction thinks in physical geography. It thinks in areas, this module over here, that deck over there. It's all about physical boundaries. But commissioning couldn't care less about geography. It thinks in systems. It acts much more like an interconnected biological nervous system. Take instrument air, for example. It doesn't just sit politely in Module A. It travels absolutely everywhere it needs to go, cutting right across all of those physical modules you literally just spent months building. And, this brilliantly illustrates a core truth about offshore engineering. The very day you make this mental switch from area-based thinking to system-based thinking is the exact day your static structure actually starts becoming a live facility. You can't just tick a box anymore saying, all right, Module B is done. No, you have to ask, is the entire firewater system operational across the whole platform? It completely reorients your whole project execution strategy. Section 1, the system dependency tree, or the anatomy of a life system. Let's move to and see how this builds. Because once you're thinking in systems, you'll quickly realize they are definitely not all created equal. You're dealing with a really strict hierarchy of operations here. Sitting right at the very root of this dependency tree are two critical lifelines: instrument air, and the hydraulic power unit, or HPU. Why are they at the root? Well, because almost nothing else on your multi-billion-dollar platform can be commissioned without them. Control valves absolutely need air to stroke. Subsea and shutdown functions, they completely depend on hydraulic power. The whole shebang branches off from these two roots. So the crucial point is this: instrument air and the HPU have got to go live first. If you commission these late, it honestly doesn't matter how spectacular your progress is on the rest of the topsides. Every single downstream system is going to queue blindly behind them. You could have dozens of subsystems sitting there perfectly ready to go, but they'll just be completely paralyzed, waiting on that air and hydraulic power. All right, so once those root systems are live, you move into verifying the nervous system itself through loop testing. Now, what's a loop? It's the complete end-to-end path. It starts way out at a field instrument, travels through junction boxes and marshalling cabinets, goes all the way into the DCS, that's your distributed control system screen, and then travels all the way back out to the final element, like a valve. We prove this path is flawless using insulation resistance and continuity tests, tracing that signal until the full path lights up green. And listen, you have got to prove it across the entire path. Why? Because of a golden rule in commissioning. Every failure you'll ever chase lives at a termination, not in the middle of a cable. It is so incredibly tempting to test a loop segment by segment just to save time, but if you do that, you miss the exact places where things actually break. The vulnerability isn't in a long run of copper. It's right where human hands stripped a wire and screwed it into a terminal block. That's exactly why proving the loop end-to-end is totally non-negotiable. Section 2, location economics. Workshop versus roadside. Now, what's really interesting about this next concept is that every technical rule we just talked about is governed by a pretty harsh financial reality. Where you choose to do this work will absolutely make or break your commercial success. Just think about fixing a car. In a fully equipped workshop, which represents your onshore yard, a mechanic has a hydraulic lift, every single spare part, specialized tools, and perfect daylight. Now, picture that exact same mechanic fixing the exact same fault with the same parts, but they're stranded at the side of the highway in the pouring rain holding a flashlight in their teeth. That is offshore hookup. Whatever work you deliberately leave or even accidentally push to the offshore phase, you are paying to do it at the side of the road in the rain. And honestly, the roadside penalty is staggering. The onshore yard hour is a small, relatively predictable cost, but that offshore hookup hour, it climbs right off the charts. When you're working offshore, you're not just paying a technician's hourly wage. Oh no, you are paying for highly scarce platform bed space, helicopter transfers, weather downtime, complex permits to work, and an entire workforce on rotation. Every single hour pushed from the yard to offshore carries a massive cost multiplier. Which leads us to a genuinely tough, real-world scenario. Let's say you're the project director. You've got 200 loop tests left to complete. Finishing them onshore in the yard is going to delay your sail-away date by exactly 5 days. So what do?
Do you hold the vessel and do the tests, or do you sail away and just do them offshore? This is where your grasp of location economics is really put to the test.
Let's run the math. A standard benchmark penalty for a delayed sail away is, say, $1 million a day. So those 5 days in the yard, that'll cost you a clean $5 million. I know, that feels like a massive, unacceptable hit. But what's the alternative here? Executing 200 loop tests offshore means mobilizing a specialized team, securing helicopter flights, paying for premium offshore bed space, and absorbing the risk of weather delays just wrecking your schedule. That offshore campaign could very well exceed $5 million. Or, depending on your setup, maybe it won't.
So, the crucial point is this. The mistake in this scenario isn't necessarily picking the yard or picking offshore. The fatal mistake is making this massive executive decision based on a gut feeling. You absolutely cannot let the fear of a $5 million delay penalty push you blindly into what might be a $10 million offshore mobilization. You have to take the emotion out of it, evaluate the true offshore multiplier for your specific project, and run the actual numbers.
If you joined us for part 1 of this explainer, you know you need flawless ITRs and punch discipline to even get to this stage. But to successfully bring that static structure to life, you've got to transition to system-based thinking. You have to respect the dependency tree, getting instrument air and HPU live first. You absolutely mandate end-to-end loop proving. And financially, you maximize your onshore scope to avoid those punishing offshore multipliers, defending your schedule decisions with hard math rather than just opinions.
So I'll leave you with this final thought to chew on for your own projects. When the pressure is really on and the yard is screaming at you to just ship it and fix it later, are you making your executive offshore decisions by instinct, or are you truly ready to run the numbers for your next sail away? Thanks so much for joining me on this explainer, and I will catch you next time.